Okay, this is lab 3, and I'll go through all the key steps that we did in the class and a few more things. So the first thing is that we have to click RLAB03, which I've already done, and it opens into web browser, and here are all the steps that we'll go through in this video lecture. At the same time, the first step is to download student.csv file. So I'll go to the desktop, I'll create a new folder, and I will call it RLAB03. And this is where I'll store all the files, or if I have to write a file, this is where it will go. And this will be my working directory. Okay, so the first thing we have to do is to download student.csv. So let's go over here, give it a right click, save link as. I'll go to desktop, I'll click RLAB03, and I will save into this particular folder. Now, once I'm done with that, let's go to RLAB03. And let's give it a right click so that we could get the property and then the location of the file. So copy this location. Now open RStudio. And here we'll set the working directory to this location that we just created. Change the direction of the slashes, otherwise you'll get an error. Okay, so this is done. Just to double check, do get working directory, so that is all correct. Do list.files. I'll give you all the files which are there in the working directory. So right now there's only one file called student.csv. Now the next step is to read this data into a variable in R. So we'll create a variable called teens, and we'll use a function called read.csv, which reads CSV file. And as you can see, student file is student.csv. It's a comma separated value file. So all we have to do is supply the name of the CSV file, and R knows how to deal with CSV files. Okay, so everything is done. So let's look at the structure of the data. So str stands for structure, and this whole output comes up. So teens is a data frame. So I mentioned multiple times in all the lectures that whenever you read from database or you read from files, the variable is a data frame. So it's a data frame. There are 30,000 observations in there. That implies that 30,000 rows in the data set, and there 40 variables implies 40 columns are in there. Graduation year is a year. It is 2006, 2006, 2006 is an integer data type. Gender is a factor data type. It has two levels, F and W. And then age is numeric. It is 19, 18.8, 18.3. That's continuous variable. And then friends are integer, basketball are integer, and all of this stuff are integer. Now, you must be wondering what this data is all about. As I mentioned in the class, this data is a scrape from places like Facebook and Twitter, where people post their feelings, their information. And if you have the data about all those things, you can break that data in terms of words which are being used by a person. And if you tabulate those words, okay, this person is heavily into tennis, so if that is the case, then this person would be using tennis in every second sentence or third sentence or fourth sentence. So if you tabulate everything by words, you're going to see a huge number of tally for tennis. Frequency of tennis will be high versus, say, swimming, because this person doesn't know anything about swimming. So for swimming it would be 0, but for tennis it would be high. So just based on that aspect of the data, you can say, okay, this person is into tennis. So that is what this data is all about. Each row corresponds to a student, and that for that student we capture graduation year of that student, the gender, the age, how many friends this person has, and then what this person is talking about in his profile, in all the things that he's talking on Twitter or Facebook. And that is what these friends, basketball, football, soccer, softball, all these things are. These are just words which occur in various posts or the profile of a person. So that is what this data is all about. So structure gives us all this information. Now let's look at the spread of the data. And for that, we use a function called summary, which we have already used multiple times. So let's look at the summary of teen. And this summarizes all the variables that we have in our database. Okay, so the first, uh, okay, so we look at the summary of all the variables that we have. And the first thing that catches our attention is gender variable. So if you look at gender variable, we got, of course, two factors, two levels of the factors, female and male. The data is predominantly female data, so 22,000 out of 30,000 are female and only 5,000 are male. And the thing that is really important for us from k-mean perspective is that there are 2,724 missing values. So as you know, k-mean clustering is all about distance, and if one of the variable has missing values, then you can't use it. I mean, that's going to skew up the whole algorithm. So we'll have to do something about it. At the same time, gender is a categorical variable, so we'll have to use some technique through which we could convert gender variable into numeric variable. And the way to do that is through a concept called dummy variables, which if you have taken statistics class and have worked through linear regression, you must have done that. So in dummy variables, all we do is we look at whether the data has, say, for example, F or not. So if person is female, then dummy variable for female will be 1, otherwise it will be 0. Similarly, we'll create a dummy variable for, say, um, gender unknown. And if gender is not known, then it will be 1. If gender is known, then it will be 0. And then after this, we do not have to create any dummy variable for M, because if we know this person is not a female and we know that this person's gender is known, that implies this person is male. That there is no fourth possibility. So this way, we can convert gender variable into dummy variables, and our gender variable will have two dummy variables. One is for F, which could have 0 or 1, and the other is gender not known or unknown gender, which could be again 0 or 1. Now let's move on to age, and age also has some funny things happening. One is the minimum is 3 years and the maximum 107 years. So there's some bad data into age variable. So we'll have to do something about it. We'll have to remove these outliers or bad data, and we'll have to replace it with NA or not known or null values. And along with that, there are already 5,000 NAs in there. So we'll have to do a similar kind of treatment or some other treatment to get around this NA problem. Now, unlike gender, which is a categorical variable and we use dummy variables, in age we cannot use dummy variable because age is continuous variable. So in order to get around the situation is um, we'll use a technique called imputation, where maybe we'll take the mean or we'll take the median, or in some cases you may even run, say, regression models to predict based on other variables what a person's age is. In this case, it's not so difficult. If we look at graduation year, it is heavily dependent, the age of a person is heavily dependent upon graduation year. So if the person is doing fine academically, then based on the graduation year, they'll be apart by 1 year. So 2006 will be 1 year senior to the person who's graduating 2007, 2 years senior to a person graduating in 2008. So we can exploit that fact, that relationship, and we can impute age and get around the issue of NA. Now for friend, everything looks fine. For basketball, football, soccer, everything looks fine. One thing that will catch your attention is that minimum are 0 for all these variables, which is all fine, because if you look at text mining data where every variable is actually a representation of a word, words could be 0. Usually they are 0 in text mining. An example is that if you have documents mixed up, where some documents correspond to medical sciences, some documents correspond to law or economics or finance, there are certain terms which are used only in medical sciences. So in that case, there'll be some maximums which will be coming out of those documents where the document is about medical sciences and they use those terms. But in other documents, they will be simply absent. And that is where the minimum zeros are coming from. So based on that fact, everything looks pretty ordinary. There's nothing out of ordinary over here. So that is all fine. Let's move on to the next step in our script. So the next step in our script is to look at the gender variable a little bit closer because we know there are a bunch of NAs in there. So we'll do something called table, which we have already done in lab 1 and lab 2. Table is a way by which we can create a one-way contingency table. Table works on factor variables or factor data types. So all table function does is that it will look at the distinct values of gender variable and it will do a count on each distinct value. So here it'll give us a count of how many females are there, 22,000, how many males are there, 5,000. However, one thing that'll catch your attention is that there is no mention of the missing values. So how to bring missing value in this picture? And for that, we have to modify it, this whole thing, by adding one more parameter, which is use NA. So it's right over here. We have to use NA parameter. And if we put it to be if any, it will include NA also in this table calculation. So here NA is there, which was simply absent in 22,000 in the previous step. So now we know females are 22,000, males are 5,000, and the 2,700 missing values in there. Similarly, if you do always, it will still work. So it still works. So everything is fine. Okay, so similarly, let's look closer to age variable. So let's do a summary on age variable, and we find out, okay, the minimum is 3, the maximum is 107, so there's something wrong with the data. The mean and medium looks okay, and the 5,000 missing values. Okay, now let's do something about the outliers in age variable. So in order to remove outliers or bad data, we'll use a function called if-else. Now, if-else is very similar to if-else in any programming language or in Excel also. The way if-else works is it has three components. The first component is a condition. And this condition can either be true or false. If it's true, then this function will return the second value right over here. If it's false, then it will return the third value. So the first value is a condition. If the condition is true, it'll return this value. If condition is false, it will return this value. So let's look at the condition. The condition is if age is greater than or equal to 13 and age is less than 20, that implies the person is between 13 and 20. If that is the case, if this condition is true, then return the age which is there in the data set. Otherwise, put NA. Now, one thing to be noted here is that NA doesn't have quotes around it, and still this works. And the reason why it works is because NA is a reserved word for R. R knows what NA is all about. So once it does this calculation, whatever value comes out of it, it will put that value into age variable of teens data frame. So that is what this $sign means. This implies teens is a data frame and age is a column in teens data frame. So whatever comes out of this, it will be put into this particular variable of teens data frame. Let's hit enter, and now age variable is updated. So let's do summary on teens $age. And it's way different from the previous summary that we did on the age variable. So previously the minimum was 3, now minimum is 13, which is all fine. Here the maximum was 107, now 20, so that is all fine. And if you look at number of missing values, previously it was only 5,100, I would say, around about that, and now it's 5,500. So about, give and take 400 more missing values have been added, and that is because there were 400 bad data points in there. So we took care of the bad data. Now we had to take care of two issues. One is to resolve the NA in gender and resolve the NA in age. So that is one issue. And the second is that we have to create dummy variables, convert categorical variable, which is gender, to numeric variable so that we could use in our k-mean clustering algorithm. How to do that? So that is what the next step is all about. So the next step again uses if then else statement and looks for gender variable, whether it's F or not. So this is how it works. If If else, once again, it has three components. First is the condition. If condition is true, this value. If condition is false, this value. So let's look at the condition. If teenager's gender is equal to female, F stands for female, and these double equal signs is equality condition. So if a teenager's gender is equal to female, ampersand stand for and teenage gender is not NA. Is NA means whether it's NA or not, and this exclamation sign over means not. So if teenager's gender is female and teenager's gender is not missing, in that case, this function will give you 1. If this condition is false, this function will give you 0. So that is what this function will do, and whatever value comes out of this function, put into a new variable in teen's data frame called female. So female is a dummy variable. It will be 1 when the teenager's gender is a female and teenage gender is not NA. Otherwise, it will be 0. So let's enter, and now this variable has been created. So let's look at teen structure. We'll see one more variable out there. It's called female, and it's 010101. So far so good. Okay. Now similarly, we'll create one more variable, a dummy variable, for those cases where the gender is not known. So again, I'll use if else. The first condition is whether this teenager's gender is null or not. If teenager's gender is null, that implies this condition is true, then the output of this function will be 1, otherwise it will be 0. So let's hit enter. And so this creates a new variable in our data frame teens. It's called no gender. It can be 1 or 0. If teenager's gender is NA, in that case it's 1, otherwise it's 0. That's all in plain English this function is saying. So let's do structure once again. And there are two variables right over here, 0, 0, 0, 1. So that implies here, in this instance, the gender is NA. So that is the reason why it's 1. Other cases, gender is known, so it's 0. In this case, both are 0. That implies this person is male. So that's the reason we do not have to create a dummy variable for male teenagers. Okay, so let's do something that we have already done. Let's look at the table of teenager gender, and this output we already saw a couple of steps ago. Let's look at the similar kind of thing for the new variable female that we have created, dummy variable. And it tells you that 7,946 are 0, 22,554 are 1. So this is all fine because this matches with the value over here. So this is all fine. And similarly, let's look at those cases where the value of gender is missing. So how that looks like. So here 27 to 4 are missing, so that's the reason why this variable is 1. This particular value matches with value over here, so this looks fine. And then 27 to 56 will be the addition of this and this, so this again also looks fine. So 4 plus 2, that's 6, so it's right over here. 5 plus 2 is 7, so 7 is right over here. So this value looks great. And 2 over here, and then 2 and 5, that's 7, so 2, 7, 2, 7, 6. So everything is fine. So far, whatever we have done in terms of creating dummy variable has worked fine. Okay, so all these things are done. Now let's look at the mean of the age of the teenager, because the reason why we want that is because based on the mean, we can impute what is the age of those teenagers whose age is missing. So let's look at the mean, and we get NA, null. And the reason for that is that if you have null in your data set, and if you do any kind of mathematical operation on that data set or data point or variable, it will return you null or NA. So we'll have to do something about this so that we could remove all the NAs and thereafter the mean function will work. So how to do that? So the way to do that is we'll have to use a parameter called na.rm. And we'll have to say na.rm is equal to true. What's saying is calculate the mean of age variable of teen data frame and remove NA. Do you want to remove NA? The true means yes. So yes, remove NAs when you calculate the mean of the age. So let's see what happens then. So now it has removed all the NAs and the mean comes out to be 17.25243. So now with this, we have an option. We can take 17.25243 and put it at all those places where the age is missing. Now the question is that a good approach? And the answer is no, it's not, because we know that there are certain people in this data frame or data set who are graduating in 2006 or who have graduated in 2006. There are some who are graduating in 2009. There's a difference of 4 years. So you cannot take this number and slap it onto to the entire data set. So it has to be more intelligent than that. And it goes back to what I was saying in the starting of the video. We can leverage the fact that the graduation year could be a reflection of person's age. So 2006 graduation folks will be 1 year older than those who are graduating in 2007 and 2 years older than those who graduated in 2008. So we can leverage that fact. How to take care of that issue? So for that, we'll do something called aggregation. So we'll calculate for every graduation year, we'll create a bucket and we'll calculate for each graduation year what is the average age in that bucket. So how to do that? And for that, we'll use a function called aggregate, which is right over here. And I'll just walk through this function. Okay, so what this function is saying is aggregate the data, which is teens, by graduation year, and then for age, calculate the mean. And when you calculate the mean, remove all the NAs. So na.rm is equal to true. That's what we did with mean over here, because if we do not do that, it will be NA. So once again, all it's doing is it's aggregating the data, which is teens, aggregating it by graduation year, and then it calculates mean of the age after removing all the NAs. That's all it's doing. And then it will put all these things, the output of this, into a variable called ABCD. So let's see what happens. So ABCD has been created. Okay, so now just to see what is there in ABCD, we can do print ABCD or we can simply say ABCD. It will work the same way. Okay, so it has created a data frame and we can find out what kind of object does ABCD. It's a data frame. It has 2 columns, graduation year and age, and it has 4 rows. The graduation is 2007, 2008, 2009, 2006. And for each graduation year, it has calculated the mean after removing, of course, all the NAs. And that is what this function was doing. Divided all the data into 4 buckets, 2006, 2007, 2008, 2009, calculated mean on the average after removing RMs. So after removing NAs using na.rm. So that is what this function did over here. Okay, so we got this data frame, and now what we have to do is we have to take this information, merge it with the teens data frame, and wherever we find missing value, use these 4 rows and impute the age of the teenager. In the situations where the value is not missing, then use the value which is already out there. Do not use this data frame at that time. Use this data frame only in those situations where the value is missing. Okay. With that, let's see how we can merge these two data frames. So one is teens, one is ABCD. We have to merge them together. So the syntax is this thing. We use a function called merge right over here. And then we have to supply which data frames you want to merge. So I say merge two data frames. One is teens, the other one is ABCD. Now, okay, I can merge these two, but you have to supply how these two data frames are related to each other, how these two data sets are related to each other. And the way these two data sets are related to each other is through graduation year. So every teenager has a graduation year, and here we have for each graduation year what is the mean age. So graduation year is a common link, is a common column through which we can join these two data sets, and that is what is specified by this parameter called by. So let's look at by. It says by is equal to C, and then in C we can put one or we can put many. So in this case, of course, it's easy because graduation year is the only column which is common between the two, and it's the only column that we have to use. How about in situation where we had like 3 or 4 columns, we can put all those separated by comma. So let's assume there was one more column in there. It's called class or school to match between two data frames. We could have just put comma and we have put all those columns or variables in there. But in this case, we just need one. So with this, it will merge these two data frames and it'll put into a new data frame called merge underscore teens. So let's hit enter, and merge underscore teens has both teens information and ABCD information in there. So far so good. So let's look at the structure of merged teens. And now we see like all the things that we created, like these dummy variables are out there. All the things that we did to teens data frame are out there, but we got more information. We got one additional variable. One is called age.y. So this is something that is coming from this data frame. So this is called y and this is called x. So teens is x and ABCD is y. So age.y is coming from ABCD, so that's 18.77777. And then age.x is coming from our teens data frame from here. So it could be like 19, 18.8, 18.3, 18.9, and 19, whatever. So our trick is, the plan is that if this value is there, that's fine. There's no problem. If this value is missing, then we'll look at age.y and we'll take that value for age. So that is what we'll do. So for that, we'll do the same thing that we have done many a times in this lab, if else statement. So we'll take we'll use if else statement, and then we'll have this condition. So as you already know, if else has 3 components. First is the condition. If the condition is true, what the value would be, that second part, and then if it's false, what the value going to be, that's the third part. So here we have a condition whether this merged teenage age dot x, which is the original age that is coming from the data frame, is that null or not null. So that's what this condition is doing. If it's null, then it will be yes. If it's populated, it's not null, then in that case we'll use this the third part. So let's run with this condition. So let's assume this condition is true. The age.x, which is the original age that we got from the data frame, is null. In that case, let's take the average that we calculated through our ABCD data frame. If it's not null, in that case, let's run with the original age that came with teens data frame. So that's all we're doing, and whatever comes out of this, put into age variable in the teens data frame. So let's hit enter and let's see what happens. Okay, so now teens age is populated with this logic, and let's do summary on teens dollar age. And now all the NAs are gone. So they've all vanished. Another thing is something that we took care of a couple of steps ago. All the outliers are gone. All the bad data is gone. So bad data has been taken care of. All the NAs are taken care of, and now we can run k-mean clustering. So